This is Dr. Carroll, and I have an exciting video today. And in the family of the divide and conquer algorithms is a foundational problem from computational geometry, and that is to find the closest pair of points. Let's see this. So here we have a whole bunch of random points, and we need to be able to find the very two closest points. This is applicable in many fields with large number of points. A naive implementation would require for each point calculating the distance to every other point and checking if it's in the minimum. We would call that a brute force approach. This would require n times n minus 1 divided by 2 distances, so that's n squared. And for millions of points, that's going to be slow. But using a divide and conquer approach, we can achieve an order n log n approach. Let's talk about that. First, make a list of the points sorted by their x values. That can be done in order n log n, so it doesn't add anything to our total order. Make a list of the points sorted by their y values. Same thing. Then 3, we're going to choose a point with the median x value to divide the space. So let's see that. That's going to be about here. Okay. Now there's 3 scenarios that we can have. First, both points have the x values less than the median. Or 2, both points have x values greater than the median. Or 3, one point has an x value less than the median and the other has an x value greater than the median. Okay, so the first 2 parts are easy, but it's the third part that takes some work. So the solution for part 3 is we're going to recursively find the closest pair of points with x values less than the median, and we're going to call that d sub l for the distance for the on the left. And for now, we'll just assume that we have a working solution and they were able to find the closest pair of points. Then we're going to recursively find the closest pair of points with x values greater than the median. And now we've solved, and we're going to call that d sub r for the distance on the right. Now we've solved scenarios 1 and 2, but we're not done yet because the closest pair of points could be on both sides of the median. It could be the third scenario. So we're going to let delta equal the minimum between d sub l and d sub r. And because we're looking for the closest pair of points, we know that they can't be further apart than delta. So let's see this. So here we have a bunch of random points, and we have the median x value of the points drawn here. And we've calculated d sub l at 7.3, and we've calculated d sub r, and it's 26.2. And so now the minimum between them is delta 7.3, and so this means that we only need to look at points whose x values are between the median line plus or minus delta. Okay, so we drew that strip in there. Now we only consider points that lie in this strip. And we iterate through the points sorted by their y values, and that's where the real creativity gets here. We only have to look at points that are within delta. So let's look at that first point there, 0.6. And we, in terms of a horizontal distance of delta. And it turns out that those 2 are the closest to. 0.6 and 4 are only 5.8 apart. And so we update delta, and then we would continue calculating each of the points within the strip with delta becoming smaller and smaller. And that's it for this video.